Bhishma Nirvana by Dr. Nilesh Oak. Chapter 7 Epoch of Bhishma Nirvana. Research is of considerable importance in certain fields such as science and history. Fred Saberhagen. We are ready to calculate the mean chronology numbers for the epoch of Bhishma Nirvana. We will do it based on two sets of evidence. One, calculation based on the lower and upper limits for the first and 10th day of the war, coupled with lower and upper durations for Bhishma on the bed of the arrows. This set of evidence provides us with 4700 BCE to 7000 BCE as the interval for the epoch of Bhishma Nirvana. Second, calculations based on the lunar months of Margashirsha coinciding with the first half of the Sharad season. This set of evidence provides us with 5642 BCE as the mean year for the chronology of Mahabharata war and hence for the epoch of Bhishma Nirvana. 7.1 Lower and upper limits. Let's begin with the lower limit for the day of Bhishma Nirvana. We found out that the Mahabharata evidence provides no flexibility for the tithi of fall of Bhishma, that is 10th day of the war, and it must be virtually fixed at Margashirsha Shukla Navami plus or minus 1 day. The variability of plus or minus 1 day is due to error that can occur in determining the tithi of the day due to the varying lengths of tithis anywhere from 19 hours to 26 hours. It so happens that in our times, Margashirsha Shukla Navami 9 is the lower limit of the tithi range for the day of the winter solstice. This means that occasionally the day of the winter solstice could coincide with Margashirsha Shukla Navami in our times as the limiting case. Now imagine, only hypothetically speaking, of course, that is, if the Mahabharata war had occurred in our times, in one of those years when the day of the winter solstice coincided with Margashirsha Shukla Navami 9, the text would have recorded something like this. Bhishma fell in the battle on the 10th day of the war. He tilted his head and looked at the sun and noticed that the sun had turned north, and thus this was also the day of Bhishma Nirvana. In this case, albeit hypothetical, we would have concluded that Bhishma on the bed of arrows was for 0 days. On the other hand, the Mahabharata text preserves for us a detailed chronological record that states that Bhishma was on the bed of arrows for more than 92 days. This means we must go backward in time, beginning with our times, for a duration long enough so that the tithi shifts by at least 92 days. We do know that the central tithi shifts by 1 day every 72 years. The calculations are rather straightforward. Beginning with our times and to achieve a shift of 92 tithis, Margashirsha Shukla 9 to Falgun Shukla 12 would mean we must go back by 92 into 72, that is 24 years before present, and subtracting 2000 years of common era CE leads us to approximately 4700 BCE as the lower limit on the epoch of Bhishma Nirvana. We estimate the upper limit of the epoch of Bhishma Nirvana by beginning with our times and going backward to achieve a shift of 125 tithis, Margashirsha Shukla Navami to Chaitra Purnima or Chaitra Shukla 15. And this would mean that we must go backward by 125 into 72, that is 9000 years before present, and subtracting 2000 years of common era CE leads us to around 7000 BCE as the upper limit of epoch of Bhishma Nirvana. 7.2 Margashirsha during the first half of Sharad season. The Mahabharata text evidence established that the war began near Kartik Amavasya and most of it took place during the Shukla Paksha of Margashirsha, and it occurred during the first half of Sharad season. This evidence allows us to estimate the timing of Mahabharata war, hence that of Bhishma Nirvana. In our times, the end of Hemanta season and the beginning of Shishir season occurs during the month of Margashirsha. We must go backward in time until the lunar month of Margashirsha coincides with the first half of Sharad season. The Yogatara of Nakshatra Mrigashirsha, Bellatrix, coincided with the point of the spring equinox around 4460, that is 4460 BCE. This refers to the time of the lunar month of Margashirsha coinciding with the fall equinox, opposite of spring equinox. We must go further backward in antiquity until the Yogtara of Nakshatra Mrigashirsha was separated by 15 degrees from the point of spring equinox. This time, when the lunar month of Margashirsha coincided with the first half of Sharad season, can be calculated to be equal to 5642 BCE. I have already shown in my previous works why 5561 BCE is the year of Mahabharata war. The mean value calculation estimated a mean year of 5642 BCE, which is within less than 100 years from the established 5561 BCE as the year of Mahabharata war. This is indeed impressive and pleasing. Thus, 5642 BCE is estimated to be the mean year of the epoch of Mahabharata war and thus the epoch of Bhishma Nirvana. Summary: the first set of evidence based on the upper and the lower limit of the first day of Mahabharata war and the first day of Bhishma Nirvana led to an interval of 7000 BCE to 4700 BCE for the epoch of Bhishma Nirvana. The second set of evidence based on the war beginning with Kartika Mausya, most of it taking place during the Shukla Paksha of Margashirsha and during the first half of Sharad season, led to a mean value of 5642 BCE as the year of epoch of Mahabharata war and thus for the epoch of Bhishma Nirvana. Chapter 8: Sensitivity Analysis. I find intelligence sexy. I find a sense of humor sexy. I find sensitivity sexy. Nicole Appleton. In this chapter, we will test the two results obtained for the epoch of Mahabharata war and or the epoch of Bhishma Nirvana for their robustness by exposing them to various known sources of errors, most of them due to the fundamental aspects of astronomy. We will begin with enumeration of these fundamentals of astronomy and the kind of variations to be expected on the epoch of Bhishma Nirvana due to their effects. 8.1 Potential sources of astronomy errors. In the astronomy world, everything is in motion. Nothing is stationary. It is then amazing and surprising that the evidence that can be analyzed and interpreted with the background knowledge of astronomy can be so decisive. This has become possible because of the long cycles of astronomy relative to the timelines of human history. And even though everything is moving, we can employ this discipline of science to know more about our past. In fact, our ability to trace specific events of the past and their chronology is very much due to some of the changes of astronomy world. These movements of astral objects also introduce certain uncertainties, sources of errors, and this can lead to variations in our computed results. However, before we can reassess our computations, we need to understand the effects due to each source of error, the magnitude of these errors, and whether the effect is going to be materially significant. We will begin with a description of error source and then analyze its importance for our computed results. 8.1.1 Lunisolar Calendar. The lunar calendar 354 days is shorter by about 10 to 11 days than the solar calendar 365 to 366 days. This leads to a change in tithi of lunar calendar for a specific cardinal point designated via solar calendar. This change of tithi within a range of days of specific cardinal point is best understood with my concept of central tithi. Thus, corrections via comprehension of central tithi is the best way to account for this gap between solar and lunar calendars. No separate correction is required due to the lunisolar calendar. 8.1.2 Adhik Masa. Insertion of an Adhik Masa or intercalary month on an average about every 2.5 years is how the lunar calendar is synchronized with the solar calendar. Adhik Masa does have an effect on the nomenclature of lunar months, that is, how a specific interval of 30 days is named in the lunar calendar. This can lead to a variation or an error in the naming of a lunar month by plus or minus 1 month. For example, at times, even when the position of the full moon is near Nakshatra Margashirsha, the lunar month might be named as Pausha. The key takeaway of this month is to comprehend that one should analyze ancient references with this plausible variation of plus or minus 1 lunar month. It may influence how a lunar month is named while an observation is recorded. It does not influence computed results. 8.1.3 Kshaya Masa. Kshaya Masa may add to the confusion of the naming of the lunar months, not unlike Adhik Masa. However, it is best to ignore visualizing the effect due to Kshaya Masa. The subject is of academic interest but not relevant to the subject matter discussed in this book. 8.1.4 Error in Tithi Estimation. While the length of a solar day is about 24 hours, the length of lunar Tithi, time taken by the moon to travel through its path by 12 degrees as measured from the earth, varies from about 19 hours to 26 hours. A typical method is to note down the Tithi at the time of sunrise. Depending on when a Tithi begins, we may have the same Tithi for 2 consecutive days or a lapse of 1 Tithi at other times. This introduces an error of about plus minus 1 day in our estimation of a Tithi for a given day. Over a period of 1 complete revolution of the moon around the earth, or within a few revolutions, the effect of this variation is cancelled out. Of course, new instances of such variations begin. All in all, it is sufficient to remember that any specified Tithi has an inbuilt error of plus or minus 1 day due to the reasons mentioned when coupled with its determination by visual means. For example, a visual observer noting down the phase and position of the moon to determine the Tithi. 8.1.5 Proper motions of Yogatara. All astral objects have their motion with respect to the background astral field as seen from the earth. Most of the Yogataras for corresponding nakshatra are selected based on their brightness, proximity to the ecliptic, and their stability related to proper motions. This selection of Yogataras has been impressive and has allowed us much investigation of the past. However, as we go back in deep antiquity, the effect due to proper motions of Yogatara can affect our calculations. On the other hand, it is also critical to recognize that this same effect can tell us more about our past too. It is hard to predict without the context if a proper motion of a given star or Yogatara will have a significant effect on the specific computation. All we can say is that in the context of the current subject of Bhishma Nirvana, the effects due to proper motions of Yogatara are of no material consequence. 8.1.6 Expected variations around the central Tithi. The expected variation around the central Tithi is plus or minus 15 days. This amounts to an error of 72 into 15, that is plus or minus 1080 or around 1000 years. It is important to remember that this error of plus or minus 1000 accounts for the error variation due to multiple sources of variation. It's lunar calendar, Adhik Masa, Kshaya Masa, and error in estimation of Tithi discussed so far. Thus, one must be careful not to correct for these multiple sources of variation discussed in an additive fashion. For these reasons, I find my concept of central Tithi useful in accounting for these errors as one-stop solution. 8.1.7 Non-equal separation between Yogataras. While mathematically we can divide the astral sphere or ecliptic into 360 degrees, we do not have this luxury to place our stars or astral markers to track positions of astral objects or astral phenomenon in the sky as desired. In addition, the proper motions of these astral objects coupled with astral phenomenon such as the precession of the Earth's axis would dismantle whatever design we come up with in no time. Non-equal separation of yoke taras or other astral objects is not the only issue when it comes to calendrical computations. For example, nomenclature of lunar months. Hard to predict movements of the moon, coupled with definitions for the designations of lunar months based on the position of the moon over a wide area of the sky, leads to much confusion in the designation of a specific lunar month, in addition to the effects already discussed due to the insertion of an Adhik Masa. The way to deal with these imperfections is to make calculations based on the positions of Yoga Tara or relevant astral objects and carry out alternate calculations based on an ideal division of the sky, which is sphere or ecliptic, etc., into equal portions. These two sets of calculations can be assessed to determine if the effect due to positions of Yogatara is of material significance. Otherwise, the unnecessary and illogical demand of pretentious precision can only lead to confusion. 8.1.8 Movement of the Moon. The movement of the moon is most difficult to predict. This has many consequences. However, the most relevant for our subject of Bhishma Nirvana is how a specific interval of time is designated in the language of Indian lunar months. Central Tithi corrections would take care of the estimation of error in our computed results. However, it is not capable of eliminating the errors in how a given individual would have designated a lunar month at any given time. These errors of designating a specific interval as referring to a specific month, for example, Margashirsha, Pausha, Magha, Falguna, Chaitra, Vaishakha, etc., occur in our times. They occur regularly in the Panchanga and are not even considered errors, and we should expect the same for ancient times. I am asked this question all the time. What is the cause of this real and apparent confusion in the designation of lunar months seen in our modern Panchanga, or researchers discussing forever the confusion of lunar months and tithis from ancient Indian narratives? It is better to start answering such questions by stating that we truly don't know. Having said that, the situation is not as desperate as it may seem. We can pinpoint specific reasons as to what causes this confusion in our times and what might have led to similar confusion in ancient times. We can also specify what cautions to exercise in researching ancient Indian narratives via archaeoastronomy. While there are 27 or 28 nakshatras, there are only 12 lunar months. And while there are only 12 solar months, an additional lunar month needs to be inserted at a periodic interval about every 2.5 years to bring the lunar calendar in sync with that of the solar calendar. And while a rule exists for determining the designation of an interval as a specific lunar month by noting down or by mathematical calculations the proximity of the position of the full moon with respect to the background nakshatra reference frame, it is important to realize that these rules are designed to take into account the reality of the hard to predict movement of the moon, the reality of the gap between lunar and solar calendar, the reality of the awkward number of nakshatras attributed to an interval of one lunar or solar month, and finally the slow but continuous movement of the background nakshatra and astral reference frame caused by the phenomenon of precession of the Earth's axis. So, what gives? What this means is that while lunar months and lunar tithis are of utmost importance in archaeoastronomy investigations of ancient Indian narratives, they should be recognized for what they are, effects due to near-Earth phenomena. This means the discussion of lunar tithis and lunar months can only occur after one has determined the plausible interval via other means, specifically via evidence related to long-term phenomena such as precession of the Earth's axis or the cycle of Earth's obliquity. 8.2 Sensitivity analysis for intervals 7000 BCE to 4700 BCE. The beauty of the concept of central tithi is such that we will be able to perform our sensitivity analysis using this single concept and by assigning errors estimated due to this single concept. Recall that we estimated the lower limit of 4700 BCE by beginning with Margashirsha Shukla 9 as the day of Bhishma fell in the battle and then counting for 92 days around 94 Tithis to Falgun Shukla 12. We know that there is a variation of up to plus minus 15 days associated with Tithis matching a specific cardinal point, in this case the day of the winter solstice. We can account for this plausible error by defining our lower limit as 4700 BCE plus or minus 1080 years or 3700 BCE through 5700 BCE. What is important is to note down the newly arrived lower limit of 3700 BCE based on this sensitivity analysis. Recall the calculations leading to 3700 BCE as the lower limit for the epoch of Bhishma Nirvana is based on the most conservative assumptions made every step on the way, and thus we can say with great conviction that the epoch of Bhishma Nirvana and hence the chronology of Mahabharata war cannot be later, even one day or a year than 3700 BCE. This falsifies practically all alternate claims for the chronology of Mahabharata war. Similar analysis on the upper limit of 7000 BCE would lead us to the uppermost limit of 8000 BCE for the epoch of Bhishma Nirvana. It is important to realize that we are doing these sensitivity calculations to test the robustness of our conclusions. We are not saying that the Mahabharata war or Bhishma Nirvana occurred anywhere close to 3700 BCE or 8000 BCE. Rather, the point of emphasis that is worth comprehending is that these events did not happen any time after 3700 BCE or before 8000 BCE. 8.3 Sensitivity analysis for mean year of 5642 BCE. The mean year of 5642 BCE, when the lunar month of Margashirsha coincided with the first half of Sharad season, was calculated by aligning the position of Yogatara of the nakshatra Mrigashirsha corresponding to this location for the first part of Sharad season. The sensitivity analysis for this mean value can be performed rather easily with the help of central tithi. The central tithi inherent in the calculations of mean year of 5642 BCE is that of Margashirsha Purnima or Shukla 15. The lunar month of Margashirsha would have continued to be the first month of Sharad season over a period of 5642 BCE plus or minus 1080 years, that is from 4562 BCE to 6722 BCE. Again, the point of emphasis worth comprehending is that the Mahabharata war occurred sometime between 4562 BCE and 6722 BCE. If we add the assertion of the Mahabharata text that the war began on Kartik Amausya and that most of it took place during the Shukla Paksha of Margashirsha, then we can further refine the mean year from 5642 BCE to 6205 BCE. That is by centering the Shukla Paksha of Margashirsha around the first half of Sharad season. This would mean the Mahabharata war occurred sometime before 5125 BCE and after 7285 BCE. Summary: sensitivity analysis allows us to check the robustness of our conclusions. We did just that. For the inference arrived via two specific sets of evidence. Based on the evidence and the corresponding sensitivity analysis of the lower and upper limits for the day of Bhishma Nirvana, the epoch of Bhishma Nirvana and the Mahabharata war happened sometime before 3700 BCE and after 8000 BCE. Based on the evidence and the corresponding sensitivity analysis of Margashirsha as the lunar month of the war and that it occurred during the first half of Sharad season, The epoch of Bhishma Nirvana and the Mahabharata war happened sometime before 4562 BCE and after 6722 BCE. Based on the evidence and the corresponding sensitivity analysis of the war beginning with Kartik Amavasya occurring during Shukla Paksha of Margashirsha and the month of Margashirsha during the first half of the Sharat season, the epoch of Bhishma Nirvana and the Mahabharata war happened sometime before 5125 BCE and after 7285 BCE. The combined outcome of sensitivity analysis produced a crisp interval of about 1600 years, that is 5525 BCE to 6722 BCE, for the epoch of Bhishma Nirvana and of Mahabharata war. Chapter 9. Truth Likeness. Measure what is measurable and make measurable what is not so. Galileo Galilei. 9.1. Science and theories. In a scientific world, multiple theories exist as a plausible solution to a specific problem. In most cases, it is not difficult to determine which among those multiple theories is the best theory at any given point in time. This is because the empirical observations and results are not debated. On the other hand, in case of history research, the textual evidence can have multiple interpretations. In addition, researchers proposing new theories may assume drastically different fundamental suppositions, for example, astronomy versus astrology, or diametrically opposite views, for example, planets versus comets. To overcome this challenge, as objective comparison between two theories, the efficacy of a theory is tested by measuring its ability to explain the phenomenon it was conceived to explain. This efficacy can be quantified. The theory must achieve this without compromising its own consistency. The efficacy of a theory is also assessed via the following qualitative criteria. 1. Ability of the theory to explain a phenomenon not explained previously by other theories. 2. Ability of the theory to preserve the success of previous theories. 3. Ability of the theory in making new predictions not made by previous theories and or not possible due to previous theories. 4. The new predictions so made by the theory come to fruition, and that is, they come out true. 5. Ability of the theory to lead to growth of knowledge via new predictions and inferences of the theory, suggestions of new experiments, generation of new problems of higher complexity, and overall growth of knowledge. The last criteria of overall growth of knowledge is vague. However, it is still listed to include anything that is missed by these 5 points. 9.2. Truth Likeness Score. Let us focus on the quantitative criteria of the theory. The criterion was suggested by Sir Karl Popper and is called either Truth Likeness Score or Verisimilitude Score. We will stick to the use of Truth Likeness Score (TS). Truth Likeness Score (TS) reveals the quantitative strength of the theory or claim without wishing away any observations that might conflict with the assertion. A truth likeness score of a theory can be defined as truth likeness score TS is equal to number of observations corroborated by the theory minus number of observations not corroborated by the theory. 9.3. Physical and Historical Sciences. Let us return to the world of ancient history and chronology research. In science, a theory proposed to solve the identical problem must evaluate all the relevant data or evidence, objectively test all data or evidence, and then compute the truth likeness score. This is also required of a theory proposed to solve the problem of chronology of ancient events. Unfortunately, the majority of history researchers are ignorant of this requirement. For example, about 60 Mahabharata researchers and about 12 Ramayana researchers have proposed astronomy theory to claim chronology of these ancient events. On the other hand, almost all researchers have selected only arbitrary sets of data to test their theories. We can show that all of them chose a different set of data in a selective manner to find corroboration for their claimed chronology. We can also show that the data or evidence avoided deliberately or ignorantly by these researchers would have falsified their claims instantaneously. Against this background, I wondered if it was possible to develop a method to critique individual theories or claims and compare them amongst each other. 9.4 Truth Likeness Method TM Trademark. The Truth Likeness Method trademark combines a quantitative measurement of truth likeness score TS with the qualitative assessment of a theory or claim into a combined report. 9.4.1 All relevant evidence. All the principles and logic of physical theories apply to theories for determining the chronology of ancient events. The specific point we had to insist for historical theories or claims was that of the inclusion of all relevant evidence. Since there are more than 100 theories and corresponding claims based on selective evidence, it is of paramount importance that each of these theories or claims should be tested against a maximum number of data or evidence or observations, irrespective of if a specific researcher has tested the specific data or evidence or observation or not. 9.4.2 Consistency of a theory. In a field of physical sciences, a gap between evidence and ability of a theory to explain all evidence or observations is considered acceptable. On the other hand, a contradiction or inconsistency of a theory in explaining the evidence would immediately lead to dismissal of a theory. The demand of theories for chronology of ancient events should have been no different. Unfortunately, the rot of illogical methods combining of dogma with testable evidence, blatant ignorance of evidence that would falsify a theory instantaneously, lack of awareness of the need to expose one's theory to several tests and to welcome open criticism by fellow researchers is alien to the majority of researchers in this field of ancient chronology research. Education of these researchers on the basic method of logic and scientific discovery would take time. Since the majority of theories of the corresponding claims would fall like a house of cards, we would expect severe resistance from these researchers. It is hoped that both producers and consumers of such research comprehend the seriousness of the issue and act quickly. 9.4.3 Introduction of Auxiliary Hypothesis. The next problem is that of researchers employing auxiliary theories or hypotheses. The introduction of auxiliary theories by itself is not a bad thing. A good number of inventions and new insights to existing theories in science have occurred due to such auxiliary theories. However, what we must insist is that auxiliary theories should lead to testing of so far untested observations and not lead to explaining away of such observations. Thus, the introduction of a new auxiliary hypothesis should lead to either additional testing of already identified evidence and or identification of new evidence in the light of this new auxiliary hypothesis. 9.4.4 Falsification of theories and claims. The next issue we need to address is that of evidence and testing of which leads to falsification of numerous claims. The majority of researchers of ancient chronology are simply illiterate when it comes to inferential acumen and fail to comprehend falsification of their claims by decisive evidence such as AV observation or evidence of Bhishma Nirvana presented in this book. We can address this issue by simply listing the number of instances the theory or claim has been falsified. 9.4.5 Non-testable evidence. It is not unusual to run into the evidence that passes the test of relevance with respect to the theory proposed. For example, astronomy theory of visual observations. On the other hand, the descriptions of the evidence may not lead to clear interpretations and thus may lead to non-testability. The problem becomes worse When a piece of evidence can be tested in the light of one theory but leads to non-testability in the light of another theory. We can address the issue by listing the instances of non-testability irrespective of whether another researcher or theory succeeded in testing such an evidence or not. 9.4.6 Qualitative Assessment. A qualitative assessment of a theory based on the 5 points criteria outlined in section 9.1 should also be part of the overall assessment of the theory. 9.4.7 Truth Likeness Score. Insistence on the usage of Truth Likeness Score TS leads to the transformation of evidence from the world of metaphysics, means views, opinions and agreements, to the world of objective testing. This also leads to transition from the illogical methods of arbitrary or selective evidence usage to the logical method of using all relevant evidence. The scientific method insists on inclusion of all relevant data or evidence in calculating the truth likeness score. In addition, it is also important to recognize the hierarchy of evidence, auxiliary hypotheses, background assumptions, and inferences. This hierarchy for a specific theory or claim can be defined with the help of few basic rules. 1. Only those things, background assumptions, evidence, ad hoc hypothesis, etc., that lead to an inference are below the hierarchy of that inference. 2. Eliminate all ad hoc hypotheses that do not contribute to the testing and outcome of the theory or claim. 3. The truth likeness score can be calculated at any stage of hierarchy. The overall truth likeness score is the cumulative truth likeness score of previous stages in hierarchy. 4. No double counting of evidence if the same evidence has been contributed multiple times to stages in hierarchy above or in parallel. 5. No points for background assumptions employed. 6. No points for introduction of ad hoc hypothesis. 7. The TS hierarchy should be mapped top down. 8. The calculations of TS score should be done bottom up while assuming no double counting of evidence takes place. An illustration of this hierarchy of truth likeness score for the case of my theory and claim, that is Mahabharata war, is presented below. Hierarchy level 1. Hierarchy level 1 shows the TS top-down diagram for the assertion of 5561 BCE as the year of the Mahabharata war. This is a demonstration of rules 1 and 7. Hierarchy level 2. The next diagram is at hierarchy level 2. This diagram demonstrates rules 1, 3, 5 and 8. The overall TS score of 57 minus 2 is the cumulative score of previous stages in the hierarchy. No points were assigned to the precession of Earth's axis since it was a background assumption. The calculation of the TS score were done bottom top. The next diagram, also at hierarchy level 2, demonstrates rule 4. The evidence that led to assertions 13 and 14 is identical and thus no TS score is shown for assertion 14. This is to ensure that no double counting of evidence takes place. The diagram also demonstrates rules 1, 3, 5 and 8. When TS scores from two diagrams above hierarchy level 2 are combined to hierarchy level 1, care should be taken to assume that no double counting of score due to assertion 10 occurs. For example, we may keep the score of assertion 4 as is, 130 minus 6, and modify the score of assertion 3, 57 minus 2, to 4 minus 0. This means a combined score of assertion 3 and 4 that would contribute to hierarchy level 1 would be 136 minus 6. 9.4.8 TS template trademark. Truth likeness score template TS template TM trademark allows objective comparison of each claim with multiple alternate claims using identical criteria. Comparison between claims before the evidence is evaluated is shown in this TS template before evaluation trademark. This is a simple illustration of the truth likeness method and how it can be applied to the research of ancient Indian history. Comparison of multiple claims after the evidence is evaluated is shown in this TS template after evaluation trademark. This evaluation would consider 6 specific criteria as suggested by Sir Karl Popper between two theories or claims as T by C1 and T by C2. 1. T by C2 makes more precise assertions than T by C1. These more precise assertions stand up to more precise tests. 2. T by C2 takes account of and explains more facts than T by C1. 3. T by C2 describes or explains the facts in more detail than T by C1. 4. T by C2 has passed tests where T by C1 had failed to pass. 5. T by C2 has suggested new experimental tests not considered before T by C2 was designed and not suggested by T by C1, perhaps not even applicable to T by C1, and T by C2 has passed these tests. 6. T by C2 has unified or connected various unrelated problems not addressed by all existing or previous theories and claims. TS, Truth Likeness Score, combines the idea of truth and of content into one measurable number. It goes without saying that my theory of visual observations of the sky and the claim of 5561 BCE as the year of Mahabharata war scores high on all 6 criteria of comparison between any two theories and of truth likeness score 210 minus 5. Thus, while there are 130 plus competitors for the year of Mahabharata war, when it comes to 5561 BCE, there is no competition. The story continues in chapter 10.